All right, welcome back. So we've spent a lot of time taking apart the key pieces of AI systems, things like lifecycle, authority, and all those controls. But here's the thing. Knowing the parts is only half the battle. The real magic, and I mean the real key to building safe, governable AI, is understanding how all those pieces fit together. So today, that's exactly what we're going to do. We're going to build that single, unified picture.
Here's our game plan. We're going to start with the main problem we're trying to solve, alignment. Then, we'll do a super quick recap of the foundational pillars we've talked about before. After that, we get to the good stuff, the master blueprint, the control plane that connects everything. From there, we'll see exactly how this blueprint helps stop system failures before they happen. And, crucially, we'll get really clear on what this framework is for and what it isn't.
Okay, so let's dive right in with the central challenge, which is all about alignment. Look, it's just not enough to have good individual components. A system's safety and, frankly, its effectiveness depend entirely on how those components connect and work together. Without that integration, you don't have a coherent system. You just have a collection of parts.
And that leads to a question that I think haunts a lot of AI projects. We see these incidents happen all the time, and when we look back, they almost always feel, well, predictable. So why is that? The root cause is almost never a single broken part. It's almost always a failure in the connections between the parts.
So, to really get how those connections can fail, we've got to do a quick refresher on the core pillars themselves. Just think of these as the absolute non-negotiable building blocks for any AI system that you want to be able to govern. First up, we have lifecycle and authority. Lifecycle makes us think about how a system is going to change over time. And authority, that defines the exact moment a system can actually affect the real world. That's your risk boundary. Now here's the critical insight. By defining that authority before you ever deploy, you completely avoid that classic failure of underestimating a system's real-world impact from day one.
Next up, controls and boundaries. These are our guardrails. We're talking about things like stop conditions, approval gates, and really clear boundaries between your IT and your OT, your digital and your physical systems. These are what constrain the system's authority and, just as importantly, contain the blast radius if something does go wrong. That's how you make sure human involvement is a designed feature, not just a panicked afterthought.
Okay, so how do we actually prove the system does what we think it does? Well, it takes three distinct actions. First, evaluation. That's testing its technical behavior. Then, validation. That confirms it's actually fit for its specific job. And finally, evidence, which is the documented proof you need for audits and governance. If you skip any of these, you're not operating on understanding, you're operating on confidence. And that is a huge gamble you just can't afford to take, especially in regulated fields.
A deployed AI system is basically a living thing. It's always going to be changing. And that's exactly why operations and change are so critical. Things like monitoring and incident response, that's your system's immune system. It detects when something's off. But formal change management, that's the brain. It makes sure that the system's evolution is intentional, it's controlled, and it's safe.
And finally, none of this, absolutely none of it, works with clear organization and governance. You have to have an operating model that defines who owns what. And you need governance structures to align the system with the bigger business strategy and to manage risk across your whole portfolio. This is what lets you scale AI responsibly instead of chaotic.
So we've got our pillars, right? But the really powerful part, the part that makes this all click, is seeing how they lock together to form one single, coherent control system. So let's do it. Let's put all of these pieces onto a single canvas. This is where all those abstract concepts suddenly become a really concrete blueprint for control, which is essential in any complex environment.
And here it is. This is the blueprint. This diagram shows how everything connects, so let's break it down real quick. Notice you've got three distinct layers here. The top layer, that's the control plane. Think of it as the brain of the whole system. This is where humans and policies make decisions. Is this data valid? Is this change approved? Nothing happens without its permission. The middle layer is the execution plane. This is where the work actually gets done, in both the digital IT systems and the physical OT systems. But crucially, its actions are always constrained by the rules that are set in the control plane right above it. And finally, that bottom layer is the evidence plane. This is the system's memory. It's constantly collecting proof, audit logs, validation records, change history, and it feeds that information right back up. You see? It creates this perfect closed loop. Decisions from the top control the actions in the middle, and the evidence from the bottom proves it's all working exactly as designed.
So, the big question is, how does a framework like this actually prevent those predictable failures that we talked about at the beginning?
Well, it's all about creating discipline through design.
And I mean, the difference is just night and day. On the left, you've got all the hallmarks of an unaligned system. This is the root cause of so many failures. You've got unacknowledged authority, weak or missing controls, poor evidence, and nobody knows who owns what. But on the right, you have an aligned system. Here, ownership is crystal clear, stop conditions are designed in from the start, your audit trails are robust, and governance is proactive. The point is, these failures aren't inevitable. They are a choice, and they are completely preventable through design discipline.
Finally, and this is so important, let's be really clear about the purpose of this framework. Understanding what it does is just as important as understanding what it does not do. So this framework, it integrates all the concepts we've covered, and it gives you a really powerful mental model for thinking about and making decisions about AI systems. But, and this is a big but, it does not tell you what specific tech to use. The tools you use might be totally different. And it absolutely positively does not approve any specific system for deployment or for operational use. It is a guide for your thinking, not a rubber stamp. And that brings us to the single most important takeaway of this whole thing. AI systems don't succeed because of one brilliant algorithm or one clever component. They succeed when all these elements, lifecycle, authority, control, evidence, and governance, are explicitly aligned. The whole point of a framework like this isn't to add bureaucracy. It's to force that alignment to happen by design, long before risk ever becomes a reality. Thanks so much for watching.